2, 1.
So Math with McComish today, we're going to be looking at solving linear equations with another kind of model. But just a quick review, an equation, a mathematical statement in which two expressions are equal or two sides. The variable is a letter or symbol representing a quantity that unknowns or varies at times. Okay, so in our example here, 2x is the variables, plus 5 is a constant, equals 7, which is another constant, or just numbers. Okay, numerical coefficient is number in front of the variable. Steps to solve equations. Okay, what we want is to put all the variable terms on one side of the equation and combine them, and all the constant terms on the other side of the equation and combine them. And we do that by using adding and subtracting. Okay, so we're going to do the opposite operation to get to the other side. So with our models, we're going to look at positive x as a long rectangle, positive constant as the filled in little square, and the negatives are going to be the white sides. Okay, that's going to be important. So we're going to use zero pairs. So two quantities cancel each other out to give you 0. So if we had 1x and then negative 1x, those would cancel to give you 0. Same with, let's say we had two positives, we would need two negatives, those cancel to give you 0 pairs or 0. Okay, so let's look at an example. This middle line here, that's going to be our equal sign when we model these. So we have 3 x's. Okay, 1, 2, 3 x's equal to 9 constant. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what we want to solve for in an equation is what is 1x, or what is my unknown amount? Okay, well obviously 3 times a number equals 9. Well, we know what that is. But what you're going to do is end up dividing these. We have 3 on this side, so we need 3 equal groups of constants to match up with each of these. So 1x is going to equal positive 3. Okay, if we look at this example, 4x, so we have 4 positive x's, equals 12. Positive 12. I'm just going to clone these. Okay, so we have 12. Now, if we split those equally among 4 x's, so since there's 1, 2, 3, 4 of them here, we need 4 equal groups here. Well, again, in this case, x is going to be, there's 3 in each group. So I make equal groups. These were easy because I had variables on one side already and constants on the other side. This one's a little bit harder because I have variables and constants on one side. So let's work through this one. I have 3 x's, and I also have, we're going to pretend that this is a negative 4 because it's minus 4. So this is 4 of these ones here. And I have positive 2 on this side. Now, what I need to separate my constants and my variables, well, to do that, what I want to do is I want to get these over to the other side. Okay, the way we're going to do that is using 0 pairs. So to cancel those off that side, I need to put 4 positives. But because of preservation of equality, if I put 4 positives on that side, I have to put 4 positives on the other side. Kind of like the balance model and preservation of equality. Whatever you do to one side, do the other. Now, these ones I get rid of because they're 0 pairs. They're equal to nothing. So now I have variables on one side, constants on the other. I have 1, 2, 3 variables, so I need to make 3 equal groups on this side. And one of them, x, is equal to positive 2. If I wanted to check my answer, I'd go up here. I'd go 3 times 2 minus 4 and that needs to equal 2. Well, 3 times 2 is 6. 6 minus 4 equals 2, so I am correct. Okay, let's do 3n plus 2 equals 8. So 3n plus 2 equals 8. All right, now I need to isolate my variables and my constants. So I need to get rid of these two constants. So to do 0 pairs, I'm going to add 2 negatives. Okay, that would cancel those out. But if I do that, I have to add 2 negatives over here. Okay, now I can cancel these out. So get rid of those. And on this side now, I also have more to cancel out. So I cancel out my 0 pairs. So those are going to be gone. And I have 3n equal to 6 positives. Okay, so I'm going to split those into equal groups of 3 because I have 3 here. And n equals positive 2 again. Go back and check. 3 times 2 is 6, plus another 2 does equal 8, so I'm good. Okay, let's try this one. Negative 3x plus 3 equals negative 6. Now this one's tricky because I have negative variables, and I want positive variables because I want to know what a positive x equals to make this statement true. So what I'm going to do to make them positive variables is I'm actually going to take the variables and bring them to the other side, these ones. And I'm going to take these constants and bring them to this side. Okay, that would give me positive variables. So in order to do that, I need to make 0 pairs of variables on this side, but I have to do the same on the other side. So I'm going to add 3 x's on both sides. Okay, so what that does is that actually going to cancel out all these. So those are gone. All right, now I'm going to get these negative 6, bring them over to this side. So in order to cancel out negative 6, I'm going to put positive 6. Okay, and I have to do the same to both sides. Okay, so positive 6 there, positive 6 on here. These ones all cancel, so I can delete those. And I'm left with 3x on this side, 9 on this side, so 1x is going to equal positive 3. So that is solving with a model. We're going to try some questions on your own now. So you can pause the video, try these with the algebra tiles, solve them, and then check your answers with me.